In this video I show a minimum quantity lubrication system I made based on a car fuel injector and a garden hose sprayer. No compressed air is needed. To keep your attention, I start by showing the capabilities of this system. I clamped the injector at the tool post of my lathe. I placed a sheet 15 centimeters from the injector, that's half a feet. I filled the garden sprayer half with drilling oil. I run the injector at a pulse rate of 5 pulses per second and a pulse time of 2 milliseconds. I start by releasing the pressure of the garden sprayer and add one stroke. When I start the injector, you see it's almost spraying horizontal, even at this low pressure. These are my normal running conditions. I can run for 50 hours before I have to repressurize the container. I can run for 100 hours before I have to refill this 1 gallon 2 liter container that is only half filled. When I add another stroke of the pump and increase the pulse time to 100 milliseconds, it almost looks like a flood cooling. Let's show the system in action. Parting 15mm hot rolled steel. First I have to position the injector, so I turn the injector on. And then I can start parting. Threading metric 12mm aluminum. Position the injector. And start threading. You can see the buildup of the drilling oil. Pack drilling 10mm. Positioning the injector. And drilling. parts I use. I have a garden sprayer that has a release valve and an on-off switch with a lock. It's about 1 gallon in size, that's 2 liters in metric. I replaced the tip, the nozzle, by this aluminum version. The other end of the hose goes to an adapter, and the adapter fits on the input port of the injection valve. The injection valve is of an European car, a Citroën C3, that has a small 4-cylinder petrol engine. It fits. I made a housing. The other side. And a mounting for the package. The injector valve has 2 connectors. I marked the positive side. If you switch polarity, then the injector won't work, but it also won't damage. I 3D printed a flexible cover for the wiring out of TPU. I mounted the injection system to the chip card. It can rotate, so I can position the injector. On the front I can set the angle of the injector so it points to the center of the chuck. For easy aligning, I made a small tool, a 4mm shaft, a piece of black HPL and a center line. So when I start the injector, on the black background the lubrication fluid is clear to see. Once aligned, I tighten this bolt and I don't need to adjust anything anymore. The injector is controlled by a small microcontroller board. I used a ESP32-C3. That's this small microcontroller. It's easy to get and affordable. I use an RJ45 socket, Ethernet connection socket, for the wiring to the display. On board 2 voltage regulators. I use a step down module so that if you mount this board in a small housing, it won't heat up. This is a 3-pin connector. This is the old version. In the new version I have a 4-pin connector. 2 for the power supply, 1 for coolant and 1 for mist signal from your CNC controller. 2 connectors, 1 to connect the injection valve and 1 to connect an air valve. This board has 2 FETs, these small components, to control the injection valve and the air valve. You could use a solid state relay like this, or a housing for DIN rail.
and you can completely wire wrap the whole thing together. You don't need this board. If you have a CNC controller like Fluid NC, then you can send a PWM signal to this relay and you can control the injection valve. I made a display and a button so you can manually control this board and set the injection time and mode. It has a RJ45 breakout board that goes to the back of the display and to the rotary encoder. I made a small PCB for the rotary encoder, so the wiring is easy. I'm going to explain the setup and use of the display and the button. I connected the display using a RJ45 network cable. If you need a cable longer than a feet, 30 centimeters, then you have to add a pull-up resistor to the data and the clock line of the display. Let's talk about the info on the display. In the top right corner you see a rotating symbol. It just shows the processor board is still running. Left of the symbol, the text off indicates the system is not active. The first line shows the pin state. Every character represents another pin. The A and the B are for the rotary encoder. A capital character indicates an active line. So when you rotate the button slowly, you see the A and the B lines go active and inactive again. And if you press the button, the S for switch will go active. The C is for the coolant line, the M is for the mist line. If the air relay is activated, the R is the capital. If the injection relay is activated, the I changes to a capital I. On the second line it shows the mode. We are now in injection mode. The third line shows the frequency. I have set the frequency to 5 Hz. You can only set the frequency in the software. In the next part of the video I'll show you how you do that. The set point. In the software you can set a minimum set point, a minimum value, and you can set a maximum value. I set the minimum value to 0.7 and the maximum value is 100 milliseconds. In the last line you see a large character indicating the mode. The E is for injection, the M is for mist and the C is for coolant. And if the digits are 0, then you know the mode is not active. When you activate the mode, it shows the injection time. There are 3 modes: coolant mode, mist mode and injection mode. In the coolant mode, the coolant relay is activated. In the mist mode, the coolant relay and the injection is activated. In the injection mode, only the injection is activated. You can switch between modes by pressing the button for 2 seconds. You can activate the mode by pressing the button. You can change the set point in mist and injection mode by rotating the button. The faster you rotate, the larger the step size. After 5 seconds of inactivity, the last mode and the last set point are stored in memory. So when you reboot the system, you get back your last mode and your last set point. If you don't need a specific mode, you can disable the mode in the software. I'll explain how you do that in the next part of the video. On this lathe I only use injection mode. If your CNC controller activates the coolant line, the coolant mode will be selected and the coolant relay will be activated. If the CNC controller activates the mist line, the mist mode will be selected. If coolant and mist line are selected, then the injection mode will be selected. I have set the injection system to injection mode. When I activate the CNC controller in mist mode, the injection system will switch to mist mode and activate the air valve and the injection valve. So I activate the CNC controller. You hear the air valve switching and the injector is started and the mode is set to mist mode. I can override the signal. I can also override the mode. I can switch back to injection mode or coolant mode. And when I stop the CNC controller, the mist line will go inactive and the air valve will disengage.
I'm going to show you how to compile and upload the firmware. I assume you have already installed Visual Studio Code and Platform IO. Click on Open Folder, browse to the repository, select the firmware folder and you are in. If it doesn't show the platform ini file, click on the platform ini file. In the bottom right corner you see Platform IO installing some modules. It only does that the first time you open this folder. And after it has installed some modules, it will ask you to reload. So we do reload. Then Platform IO comes up with his welcome screen and we close the welcome screen. In the bottom right corner you see Platform IO installing some software, and in this output console there will be some messages. Installing software can be time consuming, especially if your download speed is low. You can continue compiling and uploading firmware after Platform IO has finished its installation. Browse to the section Hardware VO2. In this section I have defined the pin definition for the processor. In the section Default Injection Settings, I have set the injection frequency to 5 Hz. Also, the minimum and maximum injection time is defined in ticks. Every tick is 0.1 millisecond. Browse to the VO2 environment setting. This is the default environment. In the default environment, all 3 operating modes are enabled. In the VO2 injection only environment, only the injection mode is enabled. It seems that Platform IO has successfully updated all software. So if you now press the cleanup button, it will remove all previous compiled libraries. A green success means that the installation has gone successful. We can now compile or build. The build was successful, but we have built for the injection only environment. So we need to select the default environment. You can change the environment by clicking on the environment selection button at the bottom of the screen. You get a list of available environments. There is a default environment, and that is equal to this environment, the VO2 environment. So we select the VO2 environment. Platform.io will update the settings for this environment, and we are now compiling for this environment. So we press the build button again. The build was successful, so we can upload. Connect the board to the PC using a USB-C cable and press the upload button. The USB port will be selected automatically and the upload will start. The upload was successful, so now the board is ready to use. A quick word about the software. On the left you see a few folders. In the library folder you find two of my libraries. Class pin is a toolset for I/O pins. The U8G2 text box library is a toolbox for the U8G2 OLED library. Click on the MQL.cpp file in the source folder. On the bottom you find the Arduino style loop, which is repeatedly executed. Above you find the setup. This is where all hardware and software is initiated. And above that a lot of code to make the whole system working. There is one thing we have to talk about. The background task generates the pulse for the injector. It uses a simple delay for pulse timing. That makes it easy to port the code for another processor. The final section is about the repository. You find a link to the repository in the description of the video. In the repository you find all the information you need to build the system yourself. In the wiki you find more information and a technical description. In the case folder you find the step file for the box, the lid and the bevel. The FreeCAD design file is also included. In the injection system folder you find the step files to 3D print the injection mount. The FreeCAD design file is included. In this design file you also find the design for the fuel injector input adapter. In the PCB folder you find the Eagle files for the PCB design. There are two PCBs. A PCB for the processor board and a PCB to connect the rotary encoder. In the PCB holder folder you find the step file to 3D print a PCB holder. Click on the wiki to open the wiki. The wiki is currently under construction. When I release the video, it will be up to date. In the description you find information about how the system operates. In the PCB design, some information about the components used. In the technical data, information about the injector type, the fluid consumption, the power supply, and the estimated injector lifetime. That's it. If you liked it or found it useful, give me a thumbs up. Thank you for watching.